So thank you all very much for being here, despite it being Friday. I appreciate it. And thanks for the invitation. It's a pleasure to be here. So I want to talk to you about food sharing, and what better time to do this than over lunch. And that just shows how common food sharing is for us, and how much we take it for granted, that we share meals, we invite people over. But for many other species, things are not like that, and interactions over food are actually mainly hostile. So what I want to do is sort of go through this whole variation and the differences that we see between species, and try to convince you that food sharing is actually a good context in which to study the evolution and psychology of cooperation. So as Joan said, this is my work that I've been doing with Mike Gerwin. So actually this is sort of the outline of a review article that we're currently writing, joining forces with me knowing a lot of the primate literature and Mike knowing the human literature very well. So it's going to be sort of a highlight show of both mine but also Mike's research, trying to tie it into a sort of coherent story. So I apologize, because this is going to be one of those stories about everything. So naturally, I'm going to sacrifice some depth for breadth, but I hope that it will be interesting and entertaining. Okay, so as I said, food sharing can be a good window to study cooperation. So why food sharing? So first of all, let me define food sharing as the unresisted transfer of food from one individual to another. And as E.O. Wilson pointed out very eloquently, other than suicide, no behavior is more clearly altruistic than the surrender of food. So obviously we have a behavior here that requires some explanation in terms of its evolution. And it's also interesting in terms of the underlying psychology. So to me, food sharing is interesting because it sort of provides a naturalistic context in which we see such altruistic behavior in daily interactions. And so thereby it can serve sort of as inspiration and maybe also a source of interpretation for more experimental studies and maybe also theories of cooperation. And that's an argument that we've tried to make in this review article that was published 2 years ago, where we basically say that what matters for what rules behavior are those decision rules that sort of evolved in naturalistic context, where on average they produce fitness maximizing behavior. And so it's important to understand what those natural contexts are, and why a certain type of decision rule might have been favored by selection. So there are basically two big pictures that I'm going to try to explain, or that we're trying to understand. So one is sort of this distribution of food sharing across different species. So this onion graph just shows distribution of food sharing that we see across primate species. So there are many species where you don't see any food sharing. Then in a subset of those, they're sharing with their offspring. In another subset of those, they're sharing among adults, and then that can be divided into sharing between the sexes, so mainly from males to females and within the sexes. And then at the innermost layer of the onion, we're left with one species ourselves, where food sharing is really common and widespread. So what we want to try to understand is sort of the factors that map onto this distribution, and that can help us explain the conditions under which food sharing might evolve. And on the other hand, we sort of have this picture of sharing psychology that's also very different across different species. So these are data that I've compiled for that other review article, where we basically took all published descriptions of types of food transfers, and I divided them into these different categories, where proactive is sort of when a food owner initiates transfer by approaching or calling another individual, whereas reactive is some form of behavior that's conducive to transfer in response to another individual approaching and begging. So something like one individual begging and the other one handing over food. And passive transfers are just when owners are not doing anything, they're just doing their own thing, but they allow others to take without resisting. Whereas forced transfers are claiming by force despite resistance, and finally resisted are when no transfer occurs. And so we have this sort of difference across different species, and And so here the n refers to the number of studies that I found that had sort of that level of detail. And so on the one side we have species like the squirrel monkeys, where interactions over food are mainly agonistic. And then, great apes, even when they're sharing with their infants, they're still largely only passive transfers. So that's shown in this bar. So, for instance, I spent half a year observing orangutans, and really the mothers are just sort of going about doing their own thing, and they don't really respond to what the infant is doing, and the infants are sort of responsible themselves for grabbing whatever food they might need, and the mothers sort of barely tolerate that, but there's hardly any active form of giving, which is sort of counterintuitive for us. Like, why wouldn't you give food to your offspring? But in fact, when ape mothers do that, it's usually they give away the sort of scraps that they don't want for themselves, so that they can keep the good parts. And then pretty much the same story among adults in apes and other species. Sort of this selective passive sharing, very little active giving. And I know that Joan has an interesting story to tell about the difference between active and passive. So, and then we have species like the callitrichids, where you have twin births, very highly dependent offspring that have very high growth rates that are not sustainable by lactation alone, so you need additional energy inputs. And so there's sort of this more active food transfers from allo mothers, so parents, so dads and older siblings that give these food offering vocalizations, thereby sort of subsidizing the energy flow to the offspring that allows them to have these high growth rates. And finally, there's humans. So there's a couple of studies on human children, which basically those are preschoolers, and they give one kid a bunch of stickers and another kid nothing, and then they let them interact. And so a lot of the kids will just offer one of the stickers to the other, or they'll give it to them if they ask, which is the yellow bar, or they don't ever refuse the others taking. Now, no one has really collected data like that on human adults, let alone in like foraging societies. Mike at some point wanted to collect these data, but no one thought it was interesting, so he ended up not doing it. However, we do know that in many cultures there's sort of a premium on giving food to others. It's very impolite to deny requests. Oftentimes just showing up at a meal is seen as a request that has to be answered. The Chimane will sometimes turn their back while they're eating on others, so there's some refusal. So overall the picture probably looks something like this. So this is basically the pattern that we're trying to understand. And so to sort of put that together, what I want to try to, the sort of story that I want to try to make is that we have to understand how strong the selection pressures for sharing are, and that might explain how active the sharing psychology is. So that's the picture that we want to understand. And so here's a quick outline on this talk. So first I want to walk you through some theoretical concepts regarding food sharing that are important to keep in mind. And then I'm going to go through this onion graph using phylogenetic analysis to explain this distribution of food sharing in different species. And at the same time, we're going to be looking at different case studies that are informative about the extent to which sharing psychology and selection pressures might be linked. And those are going to take turns. So the case studies are going to inform the phylogenetic analysis. All right, so speaking of theoretical concepts, so there's sort of two very basic characteristics that are the same for almost universally for all shared foods. And that's there's some asynchrony in acquisition, so some individuals are more likely to be owner than others at any given point in time. And at the same time, there's decreasing marginal value to consumption. So this can be plotted in this graph. So if you're a chimp male who's just made a kill, you're probably the only member of your community that now owns meat. So there's asynchrony. And at the same time, there's decreasing returns to consumption. So at the beginning, the meat is very valuable, but then once you've sort of eaten half the monkey, you start to care less and less about the rest of it. So that's true for most shared foods, and that's important to keep in mind. And what sort of directly follows from this observation is that the marginal costs of giving away food are always going to be much lower than the marginal benefits of receiving food. And that's the very basis for tolerated scrounging arguments, which basically state that it's the relative need of owner and recipient that drive food transfers. And this has been nicely simulated here by Bruce Winterhalter, where essentially you have two players and you start out with the producer having this quantity of food and the scrounger having no food. And so if you imagine them interacting over like this much food, the marginal costs of giving away this food are pretty small for the producer, but the marginal gains for the scrounger are actually really high. And so there's this difference in relative need, and so if both have sort of similar resource holding potential, similar fighting power, then transfers should occur. And then the same if you look at the next increment, still small costs and large benefits, and so eventually a lot of food will be transferred until they reach an equilibrium point. And this situation is exacerbated if you have very large packages. So if you have very large packages, you can basically give away most of it without a decrease in value. And so the tolerated scrounging model seems to apply particularly well when you have large packages and sort of similar resource holding potential in all involved individuals. But that's not the whole story, because if you have a situation in which the costs for giving a benefit are very low and the benefit you can confer are very high, then basically all you have to do is add some non-trivial relationship coefficient, and you have a situation that's favorable under Hamilton's rule. And so in addition to there being a relative difference in need, basically all you have to add is some degree of producer control so that owners can bias food flows to their relatives. And so that's argument has been made for mother-offspring sharing in apes and other species, where basically offspring gain access to difficult to acquire food by taking it from the mother, and I'll talk more about that later. Same again in the callitrichids, where you have very high fertility, fast growth rates, so there have to be food transfers to offspring. And then in human populations, you have also highly dependent offspring, but also sort of whole nuclear families that are dependent on each other. So in all these situations, food transfer is probably to some degree favored by kin selection. Also, the situation of low costs to confer a high benefit basically correspond to what Rivers called an altruistic situation. And so all you need to do is reverse the roles at some other time, and then you have situations that are favorable for reciprocal altruism. So in this case, in addition to a difference in need, some producer control, you also need to add some contingency between giving and receiving. And so that argument has been made for high risk, high yield production like big game hunting, where basically you come home empty-handed on most days, but if you do make a kill, you produce so much food that you can easily share it widely and thereby sort of store obligations to reciprocate in your community members that you then can cash in on a later date. And it's really not only the case in hunting, it's sort of what people do all the time. Like everyone produces according to their skills, and the spoils are shared to some degree. So it's the very essence of hunting and gathering lifestyle that there's that food is brought back to a central location where things are exchanged, and so you get this trade of different currencies. And in primates, we often speak of biological markets, which is really the same idea, that there's exchange and interchange of different currencies. There's grooming, agonistic support, food sharing, and so on. So this table is just to show that there is, in fact, contingency in human food sharing. So this is taken from Mike's review in 2004. And you can see that for all food items, there's significant contingency in most populations where this has ever been tested. And the same is true if you only look at meat items. Now, the Merriam are an interesting exception, and I'll get back to that later. But it's just to show that pretty much wherever you look, you get some signal of contingency. So that would suggest that transfers under this situation are favorable through reciprocal altruism. Here's just some examples from primates where we can see that not only are food transfers reciprocated, but we have contingent grooming. Grooming given is contingent on grooming received. Grooming is exchanged for agonistic support. So Gabriele Eschino did this meta-analysis. So these points are all effect sizes. And sort of the average effect size of grooming for support is an R of 0.18. So it's not great, but it's overall a significant signal. And then we have a study that I'll talk more about later where food transfers given are predicted by transfers received. And finally, we have the idea of costly signaling, which basically starts out from the observation that oftentimes there may not be any control over food distribution. So in particular with big game hunting, among the Hadza, but also some other populations, it seems that hunters give up control over their carcass as soon as they make the kill. And so it's actually others that are doing the distribution. And so there's no control. There doesn't have to be any contingency. It's often independent of need. And so in that case, food production is better understood as sort of a contribution to public good. And this is shown in this graph, which is showing data from the Merriam. So basically the important thing is the difference between the dark gray and the light gray bars, which is the amount of food that you have before sharing and after sharing. And these are just different contexts in which you hunt or collect food. And so you can see that the gray bars are really low and actually even negative in many of those cases. So people produce food, but they give it all away. And at the same time, the number of households that are recipients of the food that's being produced increases. So it seems that sharing is unconditional, not necessarily beneficial to self, and it's widespread and reaches a lot of the community members. And so people propose that it's sharing that is conveying the costly signal because it has this very high broadcasting efficiency that basically everyone who's a recipient will know about it. But the question is, what is it that's really signaled? So most people talk about a signal of phenotypic quality. So in order to be a good hunter, you need good genes, and so you advertise that by sharing your spoils with everyone. In which case, the payback sort of comes from increased social status and eventually increased mating opportunities. It could also be, though, that what you're really signaling is sort of your cooperative intent, so your willingness to share with others or your willingness to produce and contribute to the public good. In which case, the payback could also be in the form of sort of more opportunities for cooperation or future shares. Thereby sort of equating to indirect reciprocity. Okay, and so here's just how we can summarize these different concepts. So basically what really matters is the difference in need, whether there's producer control and whether there's some form of contingency. So those are the things we can look at, but of course in real life it's always going to be some combination of all these different explanations, and things like need and producer control are really going to be continuous rather than discrete variables. Okay, so that was a sort of quick tour de force over functional explanations for food sharing. So armed with this theoretical account, we can now go back to the question of what are the selection pressures that increase sharing psychology in different species. And sort of what we want to understand is how you get from no sharing to sort of rare passive sharing to widespread active forms of sharing. And so I'm going to be referring to this phylogenetic study that we did. So here's just a quick introduction. So I reviewed all the articles I could find on food sharing in primates. And those were some 200 articles which yielded a sample of 68 species for which we either knew that food sharing had been reported or no food sharing had been reported despite like considerable study effort on that species. And so we constructed this phylogenetic tree with that sample, sort of spanning the whole range of primates from lemurs to apes, and then used those comparative analysis to basically test for factors that are predictive of food sharing in different species. So the first sort of pattern that we're trying to understand is this transition from species that don't show any food sharing to those in which sharing with offspring is reported. So one of the main hypotheses that people have talked about that would explain sharing with offspring is sort of that offspring need to learn about the difficult diets, and so they need food transfers in order to acquire information about what it is that their parents or their mothers are eating. So here's some data that I collected a while ago on orangutans, where we show that actually for years orangutans will feed in the same patches as their mothers. So sort of indicating that it's hard for them to find food independently, and so they basically follow their mother around pretty much until they're weaned, at which point they're sort of expelled from the mother and they have to fend for themselves, which is one of the reasons why orangutans have such a slow life history, but that's a different story altogether. But they don't only follow the mothers around, they also actively beg or solicit food from them. So what kinds of foods are those? So here's a graph showing that basically those are begging rates, or how often they would beg for different food items, for difficult versus easy items, and difficult being the ones that the infants cannot yet process independently. So things like very tough fruits, or getting insects out of the dead wood. And so it's for those kind of items that they need the mother to basically gain access to what it is that the mother is eating. And of course, similar results have been shown for chimps in a study by Joan even before I was born.
Thank you so much.
And this is just showing that it really is about learning, because both their solicitation rates as well as the percentage of items that they beg for decrease as infants become sort of more ecologically competent and actually start to know about these food items themselves. On the other hand, it's also been proposed that, at least in the callitrichids, food transfers are really important to sort of subsidize those high growth rates. And in contrast to apes, where all transfers are sort of this passive, tolerated taking, in the callitrichids you actually see this active provisioning. So you will see adults adopting this sort of food offering posture and giving specific food vocalizations that basically invite the infants to come and take food from them. And what's really amazing is that they actually do so more often for preferred food than for non-preferred food. So those sort of high quality, high value food items, there will be more offers, more shares, and fewer refusals. So that indicates a pretty well-developed sharing psychology in which they're able to inhibit their own desire to eat those high-quality items and rather give those food calls and invite their infants to come and take it. And this is a study from captivity, but similar patterns have been reported in the wild, where they share those large grasshoppers or other large insects. So in summary, it's sort of summarized the sharing with offspring situation. Yes, there's a difference in need, so adults have usually better access to food, and offspring can gain informational as well as nutritional benefits. There's producer control as adults are sort of bigger and stronger. There doesn't have to be any contingency, and so food sharing is favored by kin selection. And so from these case studies, our prediction for the comparative analysis would be that sort of the more dependent offspring are, so the higher the benefits are that they get from receiving food transfers, the more sharing we should see, and also the more active it should be. And so for our comparative analysis, the predictive variable that we used was difficult diets. And so this is showing the result of the comparative analysis. So species with a higher degree of extractive foraging, so sort of more intense, more skill intense, more difficult foraging strategies are more likely to have been reported to share food with their offspring. And this is controlling for phylogenetic relatedness and all that. So sharing with offspring is predicted by processing difficulty, and that supports the idea that it's really learning about difficult to access food. Okay, so we've explained that sort of first transition coming from species that don't ever share food to those that share food with their offspring, which is really the transition from a easier to a more difficult diet, in particular related to extractive foraging. So the next thing we're trying to understand is why in some species there's sharing among adults, and more precisely under which conditions there's sharing from males to females, or among males or among females. So at this point it's good to take a step back and sort of think about species that don't ever share food at all, which is sort of what you would expect, sort of as a baseline mammalian pattern. So, and then you see observations like this on squirrel monkeys, where social contacts between squirrel monkeys during feeding were relatively rare, and when they did occur, they were predominantly agonistic. Attempts to steal were noted, but all were made by males and accompanied by agonistic overtones. So that's sort of what you would predict from a species that's just competing for food, where stronger, more dominant individuals take food away from weaker individuals. And similarly, it's been reported for rat colobus monkeys that food transfers predominantly an aggressive male behavior. So why would that pattern ever reverse? Why would males ever be tolerant to female taking? So here's a recent study that sort of sheds light on the beginnings of male-female transfers. And it's done on rhesus macaques, which are really not very known for their tolerance. They're very despotic species, high levels of aggression. But what they did was they had this apparatus that was comprised of those two boxes that were baited with food. And so they presented that apparatus to pairs of rhesus monkeys, and sometimes males would always approach the apparatus first, but sometimes females would be allowed to join them and eat from the same box. And so what's interesting is that was especially the case in pairs that were in consortships. So here in consortships, females are tolerated to be at the same box as the male, or at the apparatus at the same time, whereas this never occurred in partners outside of consortships. And so that sort of relates to the old Strom story, where meat sharing in the baboons really only ever happens between males and females, and it's specific to those females that are either current consortship partners or sort of the long-term bonded social partners of the males. So that suggests some form of social costs to not sharing, maybe that males would be foregoing current or future mating opportunities by not allowing those females to take. Or on the other hand, females would, in those situations, might just feel more entitled to approach males and to attempt food taking. So a study that's actually sort of demonstrated those costs of not sharing was done on orangutans. So if you're an orangutan, you're pretty much alone most of the time. and females, only give birth every 7 or 8 years. So if you're a male orangutan and you're lucky enough to be hanging out with the female, you really don't want to blow those chances. So what they did here is sort of compiled all data on food transfers or food taking attempts in those male-female associations. And so what they show is that males are much more likely to tolerate food taking by the females than the other way around. So why would they do that? Well, if males don't tolerate food taking, then the females would vocalize, they would protest, they would make a big commotion. Or conversely, if the males would try to take from the females, the same thing would happen. And so what happens when you make a big commotion, other males might show up, and there go your chances of consorting that female. So parties in which there was this kind of protest vocalizations were much more likely to be ended either by the female just moving away or by other males showing up. And so that's sort of demonstrating a clear direct cost for not being tolerant to the females. So if females keep doing that, then and if there really are mating opportunities that are being foregone by being intolerant, then in the long run, one would sort of expect an association of sharing and mating patterns then. And that's, of course, the whole debate about meat for sex transfers in the chimpanzees, where you sort of have no effect of sharing on mating patterns on some sites, but also looking at sort of more short-term intervals, whereas at different sites where you look at longer time frames, you do see an effect that males who do share meat with females actually get more mating opportunities. And so besides there being a difference in time frame, I think what's also an illuminating difference between those two sites in particular is that there's supposedly a higher degree of female mate choice in the West African sites like Thai, whereas in East Africa there's mating patterns are more influenced by male coercion. So as long as there's some degree of female mate choice, that should put pressure on the males to be compliant with females, and so you would see those long-term contingencies of transfers and matings. So to summarize this, males often have more access to preferred food. They're more likely to make kills or produce sort of high-strength food. Females might profit by increasing feeding rates, gain extra nutrients, or gain information about those males, about how tolerant they are. There's producer control because males are stronger than females, have higher resource holding potential. And there's also evidence that sharing is selective to those concert or long-term social partners, thereby indicating at least some degree of producer control. And at least sometimes we find this long-term contingency of mating due to considerable amounts of female mate choice. So it seems like the male-female sharing can sort of be explained, sure, by tolerated scrounging sometimes, but there's also some signal of reciprocity. And that is probably due to those social costs to non-sharing. So tolerant males would be preferred mating partners, or if you want to put it the other way around, intolerant males are unpreferred mating partners, so they forego current or future mating opportunities. So in a sense, females are selecting for more tolerant males. And so for the comparative analysis, our prediction was that in species with more female mate choice, you would see more sharing and more active sharing. Now, ideally, to sort of test that in a comparative context, we would have good data on female mate choice, something like percentage of female-induced matings or the percentage of refused matings. But these kinds of data just don't exist for multiple species. So what we ended up using sort of as a first approximation of female mate choice was just multi-male versus single-male species. The reasoning being that in single-male species, there's just no opportunity for female mate choice because there are no other males around. And that's also informed by studies looking at grooming patterns and patterns of aggression that show that males in multi-male groups are usually more tolerant than single male groups. So there's higher levels of grooming, fewer aggression, and so on. And so in the comparative analysis, we found that food sharing between males and females is indeed much more common in multi-male species. And then, sort of as a more detailed analysis, we looked at bibliometric measures of female mate choice and male-female sharing within those multi-male species. So basically, this is taking the number of hits you get for searching for female mate choice and species X, divided by all sort of behavioral studies on species X. So it's sort of a bibliometric frequency of female mate choice. And the same for male-female food sharing. And so that shows that at least the more often people talk about female mate choice in a species, the more often they also talk about male-female food sharing. So the argument would be that if there are multiple males for females to choose from, then that puts pressure on those males to be more compliant and more tolerant. Now, our reviewers, of course, pointed out that it could just be that in multi-male groups there are more males around, and so there are more opportunities for male-female sharing. But if you sort of think about why there are multi-male groups in the first place, it's because foraging groups are more spread out, and so females are not monopolizable by a single male. Otherwise, there would be single male groups. So proximity is actually larger in multi-male groups. Because that's when a single male cannot monopolize all the females and other males are allowed to join the group. So just based on sort of average proximity during foraging, one would actually predict the opposite, so that there'd be more sharing in single male groups. And then what's also interesting is that within those single male species, the only species where we ever see male-female sharing are in monogamous species. So in the sort of single male harem species, there's never ever any kind of male-female tolerance. Okay, so of course there's not only male-female sharing, there's also sharing in different sex combinations. So this is just showing, and I know the graphs are kind of obscured, so I sort of painted over the sharing category. So this is just to show that among capuchin monkeys in captivity, tolerated transfers occur in all sorts of combinations, and particularly also among males and among females. And similar patterns, although less frequent, have been reported in the wild. And actually, Carol and Maria have some unpublished data on Cebus albifrons, where they see frequent male-male food transfers. And similarly, in chimpanzees, we see food sharing in all sorts of sex combinations, and actually also, at least in the Thai population, as reported by Christoph Bösch, we see a considerable amount of sort of active forms of sharing. So sort of that active or reactive category that I talked about before. So who are the other individuals that they're sharing with? Who are those other males or those other females? Lots of people have claimed that there's selective sharing with kin and there's selective sharing with long-term allies. So sort of the food for support idea. And of course the question is there producer control? Is there selectivity? So to sort of illuminate those patterns of sharing among adults, and also to sort of make the link between selection pressures and sharing psychology, we did this study on chimpanzee and bonobo sharing, for which we observed two groups in captivity, and sort of used those paper bags that were filled with vegetables and fruits just to induce sharing. And so very predictably, when you provide a monopolizable food source, you'll get an owner and others who come to bag, and then the chimps sort of get these bagging clusters. And then the bonobos are sort of more tense. They don't really know what to do with this. And so if you look at overall, like what predicts food transfers given in these experiments, you can see that in the chimps there's a very strong signal of reciprocity. So transfers received was actually the strongest predictor of transfers given, whereas in the bonobos it was the opposite. So transfers received was a strong negative predictor of transfers given, sort of suggesting that transfers were just going in one direction, namely up the hierarchy. So more dominant individuals were taking food away from more subordinate ones without returning anything. And this is just to show that we didn't only test for food, but also for all those other predictor variables. And sort of across the board, we get a similar pattern. So in chimps, there's interchange for grooming and support. There's more sharing with kin. So you get all these other return benefits, whereas in the bonobos, that's much less pronounced. And so it's not surprising that when you sort of look at the different types of food transfers, that in the chimps we have a much higher proportion of those unresisted transfers than we do in the bonobos, where actually the majority of transfers are in the forced claim kind of category. And it's not just us that found this pattern. Franz de Waal actually reported an even stronger discrepancy. So chimpanzees were even more tolerant and bonobos even less. So this is not to say that bonobos are not nice, tolerant primates. They just sort of don't have this whole reciprocity in sharing thing going on. And so they just never learned to, they never evolved the psychology to engage in tolerant interactions over food. And as you might know, other people have found, have made the converse claim that bonobos are more tolerant sharers than chimps. And I recently talked to Tori about this. And sort of what we think the difference is that they really measured sharing as just there's food on the ground and do both individuals get some food or not. So it's really more the tendency to monopolize. And in that case, the bonobos have higher rates of sharing. But what we measured is really the tendency to give away food once it is already monopolized. And that in that case, it's the chimps who are more likely to do that. And it kind of makes sense. If there's benefits to be gained from sharing, then you might want to make sure that you're the one who's monopolizing the food, and then you can selectively distribute food to other individuals. So summarizing this, there's often asynchrony of acquisition. There's rank-biased ownership. Other individuals might gain access to rare nutrients. But what's also important to point out is that, in most primate species, even in the chimps who regularly hunt, shared food is still, makes up a pretty small proportion of the diet. Is there evidence for producer control? So in chimps, we sort of see these begging clusters, which already exclude a lot of individuals that are potential recipients. So oftentimes it'll already be like the allies and the kin of the food owner that are clustering around him, and they will keep away other individuals. So already by that, there's some selectivity going on, even if transfers then are explained more by tolerated scrounging. There's also reports for respect for possession, so that that individuals will not forcibly take away food from others. And there's some evidence that sharing is selective to those long-term social partners like kin and allies. And so, as I mentioned before, you would get these signals of long-term contingency with grooming, social support, basically anything you care to measure, because there are sort of these social partners, and those are the ones that are also likely to share food once you give them a shareable item. So there's probably some mix of tolerated scrounging, kin selection, and reciprocity going on. And similar to the male-female case, I think what really matters is the social costs to non-sharing. So those individuals that have shareable food but are not tolerating others to take from it might be less preferred as cooperation partners in the future. And so if they don't want to forego future benefits from having allies, or other forms of support, they better comply. And so from that, our prediction for the comparative analysis was that in species where you have more important cooperation partners, you should see more sharing and more active sharing. And so we took basically the presence of coalitions as sort of the most salient form of cooperation in primates. Many primates you can't be dominant without having coalition partners, so that's where the pressure to be tolerant with your partners should be highest. And so we used the presence or absence of coalition formations in different species to predict sharing among males and sharing among females. And so we found that in species with female-female coalitions, there's indeed more sharing among females. And similarly, in species with male-male coalitions, there's more sharing among males. And oftentimes, both coalitions may be formed among kin, and also sharing will be among kin. So to sort of exclude or reduce the sample to only sharing among non-relatives, we see a similar pattern. So there's even stronger difference between species with coalitions and species without coalitions. And again, sort of the punchline is that in species where you need allies, you need those social partners, there's some pressure to be nice to them. And so for the bigger picture, we can say that the transition from species only sharing with offspring to those also sharing among adults is probably made by some pressure from partner choice. So female mate choice, making males more compliant, and the pressure to have coalition partners leading to sharing among the sexes. I should probably hurry up a little bit, so I'll skip through that. Okay, so finally we want to understand what sharing is like in our species, why we're the only one that has very widespread or very common sharing. And so the first step to understand this is sort of to just make clear just how complex or how difficult the human foraging niche is. And this is, of course, arguments that have been made by Hilly Kaplan for a long time. So if you sort of look at the types of things that humans and chimps eat, you can see that a much smaller percentage of the diet comes from simply collected foods in humans, and a much larger proportion comes from extracted food and from hunted food. And that brings about a whole host of changes. So the difficulty of the diet increases, there's nutrient density increases, as well as caloric value, and also package sizes get larger. And so those are all changes that should lead to more food sharing. So what does it look like to sort of be a human forager? What does production and consumption of food look like across the lifespan? So all the data I'm going to be presenting now are from the Chimane population, but patterns look pretty similar in others like the Achaea or the Hadza, for which we have good quantitative data. So this graph is showing production of food, consumption of food, and then just the difference of them being net production across the lifespan. And so what you see is sort of what we know, that as kids we're basically useless. You're a net consumer until you're like between 15 and 20 years of age, and so you catch up later in life by reaching your peak production sort of in your 40s and 50s. And so that's kind of similar to the callitrichid situation, in which the offspring are really totally dependent on food flows from adults. So you have sort of this food flow from older ages to younger ages. But that's not the only thing. And so what's really unique about the human foraging niche is that it's not just offspring that are net consumers and that are dependent, but it's actually whole nuclear families that go through prolonged periods of net consumption. So this graph is just showing net production across the lifespan of nuclear families, so showing mean age of the parents on the x-axis. And so until the parents reach their 40s, the whole family is on average a net consumer, and that's really unique in primates. So one way to sort of handle this is that you have additional food flows, not only from parents to offspring, but also from older families to younger families. And that's shown in this graph, which looks complicated, but all that there is to it is that you have this sort of 3-generational pattern of food transfers, so from grandparents to parents to offspring, which is really sort of integral to the human life history. So that's the only way you can sustain a foraging niche in which your production-consumption pattern looks like that. But this is just showing on average families being net consumers, but there might be some that are higher producers than others, and others that are higher consumers. So this graph is just showing the likelihood of being in net caloric deficit, so being below that net consumption line as a function of the number of dependents that you have in your family, and also as a function of parent age. So the more kids you have, basically, the more likely you are to be a net consumer, not surprisingly. And there's also some difference between parents of different ages. So that could mean that transfers not only come from grandparents, but also from sort of smaller families to larger families. And that's shown in this analysis, which is looking at food transfers between different households. And so you get this very strong signal of reciprocity that calories from B to A predict calories given from A to B. But there's also all these interactions with kinship. So basically, those relatives in more need are more likely to be given food transfers. So this is just to show sort of how fundamental and integral food transfers are, and that they come from different sources. And so it's not really surprising that we find all these sharing norms that are in the ethnographic record. So here's just a collection of sort of sharing norms that Mike compiled for his review. So in some societies, there's very explicit distribution rules. There's a premium to share with those in need in many societies. It's very impolite to deny requests in many societies. There's also some very explicit contingencies, such as you should give to those who gave to you in the past. And also in many societies, stinginess or not giving is punished in various forms that might just be ridiculizing, making fun of others, bad gossip, to the more extreme forms of excluding them from the sharing network, or even killing them. So to get back to the bigger picture, it seems that this sort of very high interdependence of human foragers would explain why sharing is so widespread in our own species. And so to wrap this up and try to tie this to the patterns of sharing psychology that we see. So on the one extreme, you sort of have species in which there's really no gains from cooperation. They have a relatively easy diet, so there's no need to have feeding tolerance. Then you have apes, which sort of have, or other species where sort of have a difficult diet, and so infants are allowed to take, because otherwise they wouldn't learn about those food items. To those species where there's some sharing among adults, probably because the possibility for partner choice puts a pressure on selective tolerance. And then we have the callitrichids with those highly dependent offspring, high growth rates. So you need additional energy subsidies in the form of those active forms of provisioning. And finally, in humans, you have this high interdependence leading to sharing norms. Or to put it very briefly, no benefits to sharing. Sharing is sort of a necessary evil, so there's some passive tolerance to basically you or your children are dead without it. And those are really the only species in which you see those common active forms of sharing. And so, unsurprisingly, when you do economic games cross-culturally people share resources, because there's such a strong and salient is such a strong and salient feature of daily life that you pool resources, and there are all these norms demanding that you give to others. So when you put them in the situation of a dictator game, it's not surprising that people do give away part of their share. And so understanding the sharing psychology, I think, helps us to sort of interpret these kinds of experiments and put them in the context in which that psychology evolved. And similarly, we've been arguing that the different sharing psychology might explain why in the sort of provisioning games that Joan has pioneered, we see a difference between the marmosets and the chimpanzees. Because if you think about this kind of situation where the donor has to pay attention to what the recipient is getting, the donor has to actively do something to produce food for the recipient, it's sort of similar to that food provisioning, food offering thing that the marmosets at least sometimes do, but it's very different from chimpanzee sharing, in which you sort of need this begging to happen first, and there's never any owner-initiated transfer. And so possibly that could explain why in the marmosets, donors pull the tray that provisions food to others more than you do the non-provisioning tray, whereas in the chimpanzees you don't see that difference. Just possibly because the cues for this being a sharing situation are not salient enough for them. And it's not like chimps never help each other. So Shinya Yamamoto has a whole range of studies that sort of shed light on the helping in chimps. So usually there are two chimps that are in adjacent chambers, and they either need to get a token or a tool from the other chamber. And again, you never see sort of active transfers of those tokens to the other chamber. But what you do see is that they're very responsive to those kinds of requests, where there's a reach over, and then you sort of have a similar situation to the food transfers. And so they're much more likely to transfer those tools when there is this kind of request. And so that's what we've sort of tried to model, or at least sort of think about in another review article, by sort of thinking, okay, what are the things that cause pro-social behavior? And it's really sort of this mix between how responsive you are to those extrinsic stimuli, which could be things like what's the difference in need, who is this social partner, is it a kin, is it a long-term partner, is there someone else watching you? So those should all be things that make you more responsive to a request. And that would be the magnitude of this angle basically here, which, as we suggest, would be pretty low in chimpanzees, where you sort of need strong signals of need, sort of strong cues for responding pro-socially, whereas in humans that might be steeper. And also there might be some sort of form of intrinsic motivation, which is really sort of, if you strip away all the external stimuli, is there still some motivation to share? So people go out hunting even though there's no one, begging them for it. And the callitrichids give these food calls even though their infants might be somewhere else. So what we call intrinsic motivation might be some sort of combination of inhibiting your own desire to eat food or whatever it is, but also sort of having some form of conscience and thinking about the benefits that you could confer to others and the potential costs of defection. And with that, I would like to end, and sorry for taking so long. So I'd like to end all my funding agencies, Carol Van Schaik, who's my dissertation advisor, and Mike Gervin, who's now my postdoc advisor, and all my other current and past co-authors. And thank you very much for your attention.